Good evening. My name is Vivekanand, currently pursuing MTech from IIT Kharagpur. I'm going to explain my MTB, which is Master's Thesis Project, which is a 4D cardiac modeling of human heart. Uh, it is a TCS research project. Now coming to the introduction part. So, at every year, thousands of children born with a congenital heart disease. So, we need to rectify this disease because the children are going to carry this disease for the whole life. So basically, techniques like medical imaging to create a dynamic time varying representation. Basically, first we have to create a 3D model from the CT and MRI images, then to make it 4D by incorporating dimension of the time. Uh, so this is the introduction part, and after the creation of the 4D model, we will use generative AI for the generation of the same models, and which helps the doctors to predict the disease and analyze the models for better analysis. We can do a lot with the generative AI. Now, coming to the aim and objectives. So, first, I have to create a 3D model, then to make a 4D model from that 3D model. So, for the creation of the 3D model, I have used a attention 3D unit. Like this is attention 3D unit for the segmentation purpose. Then after the segmentation, I created the 3D model. So this is the encoder part where I've used the filter size of 1616, then downsampling and increase the number of filters 30 to 64 similarly. And then this is the upsampling block where I've increased the number of filters, where I have decreased the number of filters, and 512, 128 similarly. I guess. Now, coming to the data set. So, for the data set, I've used the two data sets. First is HBS1 data set, where the 60% data set, 60% MRI data set with the voxel size 186 into 256 into 90. This means the data set voxels from in the data set varies from there to there. Now, in this data set, basically, I have to segment eight parts: left atrium, left ventricle, right atrium, right ventricle, pulmonary artery, aorta, superior vena cava, and inferior vena cava. So, and the data set, this data set also uh, has a patient with a disease like including chamber dilation, ventricular septal defect, rein like double outlet. These are the defects with the patient. And the second data set is ACDC data set, which is also present in the MICAI challenge. So here I have a 100 patient data, which is 20 healthy patient, 20 patient with the previous myocardial disease infection, and 20 with the dilated cardiomyopathy, and 20 patient with the hypertrophic cardiomyopathy, and 20% with the abnormal right ventricle. Uh, Here also the box size varies from the 256 into 256 into 9 to 210 into 216 into 10. So another for the performance evolution, I have used a dice score coefficient, which is two times magnitude of intersection B divided by magnitude of A plus magnitude of B. Here A is the predictor's mass segmentation and the B is the ground truth. For the optimizer, I've used the AWW optimizer with the last function. I've already mentioned life function is dot slice and the learning rate is 0.01. I've trained it the for 50 pop with the best size of 3. So this is the result which I got on the ACDC data set. As you can see that this is the multi-class problem. So I got the IU dice score coefficient for the four classes. Like for the first class, which is basically 0.99, and the second class 0.89, and for the third class 0.85 and 0.96. So four class means basically one is background and the rest three left ventricle, right ventricle, and myocardium. So this is the four classes which I predicted like in the first. This is the samples of the some slides. So 92% dice score coefficient and the 92 and 93, 89. So this is the result which I got on the ACDC data set. So now coming to the another, basically you can see that this is the epoch versus last graph, and this is epoch versus IU. So as the epoch increases, the loss decreases, and as the epoch increases, IU value increases. Now coming to the HBSMR dataset, so this is the result which I got from the HBSMR dataset. Here I am predicting eight classes. So the dice score coefficient for the eight classes is like 0.99 for the first class, which is basically a background, and the 0.83, 0.95, 0.90, 0.90, 0.95, 0.92, 0.88, and 0.85. Basically, this is the background, left atrium, left ventricle, right ventricle, and pulmonary artery, aorta, superior vena cava, inferior vena cava. And so, mean dice coefficient 90, and similarly for the other samples, like where the mean dice coefficient is 91%. This is the same for the at the last decreases, epoch increases, and other is IU value increases as the epoch increases. Basically, I have trained it only for the 50 epoch, so this is the result, which I have shown here is for 50 epoch. Uh, for the training, purposes, I have used the three models. Like I have used attention unit and 3D unit and NN unit. So this is the result which I got on the three different models. As I got the best result on the attention unit, that's why I present only attention unit. You can see. So thank you. This is the I've done uh, till here, and thank you. Now I'm going to show the my code. So this is the code for the HVSMR dataset. Like first, the creator I've imported some necessary libraries like Nivabel for the upload of the image. Like my images dot ni that ni means Nifty images. So for the Nifty images, we have to use the Nivabel library for importing that dataset. This is the class, and this is the basic functions like image, and here I've resized the 3D balloons, convert to tensors. And here you can see that there I've only normalized the image, not mask, because mask in my mask there are one, two, three. My for the eight classes there are numbers one, two, three, four, five, six, seven, eight. For the eight classes means 0 to 8. There are nine classes for eight classes and one for the background. So for the nine classes, that's why I haven't normalized the image. Not I have not it. I did not normalize the mask. I have only normalized the image. So basically, I have resized the resized the volume. At the starting purpose, I cropped my image to 128, 128, 128, and this is the train test split. Basically, I have trained the training 90% and for the validation 10% data, and this is the data set size. This is the our class double class conversion. This is the uh, conversion block, and I've used the ReLU. I've used the instance analyzer means for the instance analyzer. I've used the instance norm 3D, and for this is the for downsampling block, and this is the upsampling block for the attention class. For the attention class, this is the column 3D and by normalization. Again, uh, class. This is the attention 3D unit. Here, this is a downsampling block. I've used the filter size of 16, then 16, 32, 32, 16. Basically, increase the number of filters, decrease the, and this is the encoder upsampling path, means the decoder path, where I will decrease the number of filters. This is our final input. Now, uh, for the calculation of here, I will calculate the IU, basically, and the dash loss coefficient. This is our main function, and this is our model attention 3D and epoch. Like here, one thing I've used the grade scaler. Basically, yeah, I've used torched AMP.autocast CUDA. Basically, my system has only 4 GB of GPU. That's why I've used the torch.amp autocast to decrease the competency power. Because my system always show that out of CUDA, because the my model complexity is too high. That's why I've used this autocast to decrease the complexity. This is the train test validation. This is the validation loop for the validation purpose, and these are the some matrices like Now here you can see that I've taken the here I can change the batch size. I've taken the batch size like 3 for that time and epoch 50, and I've changed the learning rate at 0.001 at that time. So this is my JSON file. Now the code for the both HBSMR dataset and the ACDC dataset is similar, but just a few changes. That's why I'm explaining only the HBSMR dataset. Now coming to the result, so this is the result uh, which I get on the HBSMR dataset. As I've already explained in the PPT, but here I can show you that the this is I will say type 96, 90, 87, and 91 for the class. This is the my testing purpose, my testing code for the image. I will test document for the uh, plot purpose. This is a test model and everything, image path, mask path, and so this is the my code. My result on the HBSMR dataset. Now I'm going to show the result on the ACDC dataset. So yeah, this is the result which I got on the my ACDC dataset. Like I'm predicting four classes 1, 2, 3, 4. So this is the result like 99, 90, 71, 94%, 89%, and 86. So this is the result which I got on the HV, ACDC dataset. Now by segmenting that eight parts from the HBSM dataset, I created the 3D model, which I am going to show that the 3D model which I created uh, after the segmentation part. So this is the 3D model uh, which I got from the HP Smart dataset. Okay, so I think it's good. So thank you.